In delivering a bridge like this, we face a challenge about delivering a product that is great for our passengers, that will improve the passenger experience, that is inclusive and ensure that we provide an accessible railway and that is sustainable and lasts for future generations and the generations beyond.
Simply put, footbridges were incredibly expensive and took a lot of time to produce.
The challenge to us was, can we disrupt the industry as it currently stands to give Network Rail better value for their passengers?
So we wanted to move away from an Industry 2.0 position to an Industry 4.0 where we're manufacturing and not fabricating.
We would normally fabricate a bridge in one piece from mild steel sections, weld it together and it goes off as a fabricated whole unit. This is much different. It's made from sheet material. They're laser cut panels which are then folded and bolted together. So it's a completely different method of construction.
So stainless steel has been chosen because it's a very durable material with a design life of 120 years. It's also very easy to maintain, to clean in case of graffiti.
It's a duplex stainless, which is much stronger than your normal mild steel and stainless steels, but also gives you that corrosion resistance.
If you look at the bridge, the first fault's going to be there's stainless steel cladding on the outside, but it's not. The stainless steel that you see is the actual structure of the bridge.
We know that each condition of each site is going to be slightly different. The footbridge has to be adaptable. We've designed a system where if you have a larger span, you simply add the 1.2 metre increments. If you want to change the height, you simply add the stairs as you need.
For a normal narrow configuration, we've reduced the site installation time down to 15 weeks, which was previously anything between 35 to 40 weeks. We believe the bridge and the lift system we can install in a 36-hour possession. And overall, from contract award, start of the design to handover is now a period of 20 months, where before that could be in excess of 3 years.
Potentially, you could have all your standard parts pre-made in a warehouse when you just pick the parts and produce it like you would in a factory.
The lift system has been designed specifically for the rail environment, which is a very, very constrained environment.
We found that lifts across the network were unreliable, they were breaking down, so we came up with the AVA lift system, which is essentially a plug-and-play lift.
So one of the key problems with lifts is if the drive system fails, then the lift goes out of service. We have 2 drive systems, the other one can pick up the slack afterwards. This keeps the lift in operation. We deliver a complete lift to site and stand it up and bolt it down. So from 26 weeks to 2 weeks, a massive change in installation time.
When you have a brief at the beginning of a project and you're essentially told that you've fulfilled it with an independent assessment, which we can see here, I love this diagram, you can see that AVA's actually fulfilled all of the requirements around context, passenger experience, safety, maintenance, buildability, cost, sustainability.
So it's only version 0.9. The first real version we know is going to a railway station at Stowmarket, so that is version 1.0, and we know as a project team we've got further refinements, further improvements that we can make to the product when we do version 2.0, version 3.0 and so on.
This AVA footbridge and lift system is a real demonstration of industrialised construction and what the future of UK infrastructure could look like.
Everyone that's worked on it should be incredibly proud. It is a step change. It is a completely different and unique product. It's greener, it lasts longer, it needs less maintenance. It's a completely different way of thinking.
Great design comes from a great architectural practice, working collaboratively with great engineers.
The consortium brought together some really amazing businesses. You wouldn't have got the results that we've got today if it wasn't for those teams and disciplines working together.
We was asked to design a bridge of the future, and we've done that now, so the future's here.